Okay, I got the feedback from the last video, and I'd appreciate if you drop a comment below and give me more feedback on this. I'm going to give you a lot of actionable steps today. So what we're going to focus on is getting the minerals inside the cells. Now, if they're not inside the cells, your cells don't work. So as you age, you're on the decline. This is one of the most important things you can do. Ask any biophysicist this. So number one, let me just get another pen here. We're going to show you how to rebuild your mitochondria. That means getting rid of the old, dysfunctional, beat up, worn out mitochondria and replacing them with brand new V8 mitochondria. Now, it's all for naught if you don't lower ER stress, and I'm going to give you several solutions to do that. Now, your ER is making proteins. Scientists estimate that we're making between 6,000 and 8,000 proteins, not just muscle protein synthesis. They're making these proteins for transporters. So if your endoplasmic reticulum is stressed, they're not folded correctly and they don't work properly. Now, what I find remarkable is that inside the brain, you've got these ATP pumps. So ATP pumps. And inside the cell, magnesium binds to the phosphate, the third phosphate, and the shape changes, minerals come in like magnesium. And scientists now estimate that inside the brain, these pumps, just the sodium potassium pump, up to 50% of your brain's ATP. So think about ADHD-like symptoms, lack of motivation, neurotransmission. Huge. Again, several solutions I'll provide here today. Rough endoplasmic reticulum, as I mentioned there. Like if these two intracellular levels are low, you can't engage in protein synthesis within the rough ER. So collagen is just one type. I mean, collagen is the most abundant protein in our body. I guess you want a pretty healthy heart valve and blood vessels. You also want healthy bones, tendons and ligaments, skin. Who wants to age fast? Accelerated aging and wrinkles. We want our collagen and elastin for that matter. Skeletal muscle, cornea, and your whole skeletal system. Do you want to get to 60 or even 50 and have hip replacement and knee replacements? Well, probably not. So the endoplasmic reticulum, providing we get these micro minerals inside the cell where they can rebuild these proteins, and again, underscore this, wow. Now, what about the heart? Research is in. Mitochondrial associated endoplasmic reticulum stress in your heart there. So endoplasmic reticulum, misfolded proteins in your heart. Transporters, misfolded proteins. So you got DNA damage. That doesn't sound wonderful. Lipid injury. So your plasma membrane is terrible and it goes through apoptosis, cellular death. And you've also got protein injury. And again, like the heart is a protein. So we certainly don't want that happening. Now, this is just a real short dive into heart health. So this is your endothelial cells, and you'll see here the mitochondria, right? So they're making the glycocalyx here. So that's a protective lining where your blood flows. Now, as it deteriorates and it becomes damaged, that's heart disease, plaque in your artery. Now, inside the mitochondria, in these endothelial cells making the glycocalyx, if you've got low manganese and zinc, all bets are off. So here's the remarkable thing. When we breathe, the end product of that breath is superoxide. Now, the mitochondria have an elegant system to turn it into harmless old H2O, water. So manganese binds to superoxide dismutase 2, and if you don't have enough, it all powers down. It's a helper. Then it takes it through these proteins here and turns it into harmless water. Now, in the extracellular part there, the SOD2, you need zinc and copper. So if you're low on zinc and copper, what's happening is this superoxide is busting through the endoplasmic reticulum. You get leakage, foam cells, plaque, glycocalyx damage. And yeah, you can see how this all plays out. So we got to make sure the Golgi apparatus, the rough endoplasmic reticulum, they're all healthy. And we got to have minerals inside the cells to facilitate that. Our body can do the work when we give it the right input, it gives us the right output and the right outcome for life, longevity, which leads me to this. I'm going to give you a very simple solution here to activate all the longevity genes. So what's this mystery thing up here? Well, somewhere along the way, I'm going to show you what that is, and it won't be in the timestamps. So stick with me here. Now, as I learned from this legend here, and also lots of people that I've worked with, and he's got more letters after his name than I care to count. These longevity genes, some people have won the genetic lottery. They've got good defense genes, and that's what these longevity genes do. As he says here, this explains why some people can live to be over 100 while drinking and smoking. So we need that protection, and this is a very simple solution, not hard at all. Beyond that, I'm also going to show you what this is. This thing here, really easy. It goes inside the plasma membrane. Well, let me just back up a second. Why is the plasma membrane important? Scientists estimate that we've got about 40 trillion cells. And this is the line of protection we need. So it needs to be strong, have a good membrane potential. We also need things inside it to protect it. So this thing inside it protects it from lipid peroxidization and cholesterol domain formation. So as you can see on screen now, let's talk about the plasma membrane integrity in health and disease. So this is significant. If you got this lipid peroxidization going on, and I'll talk about what causes that, you're in a lot of trouble. Now, the endoplasmic reticulum here, it's making transmembrane receptors. So if it's not working properly, and a lot of people do have endoplasmic reticulum stress, you can't make these transporters to get the minerals into the cell to do work for you. And also, when it comes to magnesium, so we need all of these things in the cell so you can live a very long, healthy life with lots of energy and enthusiasm for life. You see here, low in zinc and also magnesium. So to make proteins, you need zinc and magnesium. So you're not building a lot of muscle, you're not making a lot of collagen, you're aging faster everywhere, heart, everywhere. So ATP is made in the mitochondria. Now, when you want to use that ATP, magnesium binds to the third phosphate there, and just like a match, it phosphorylates, the protein changes, and that cell does work. Incredible. So when you've got low intracellular magnesium, you've got mitochondrial issues, membrane, liver, brain, hormones, metabolic triad, and I'll talk about that. And you've got a low zeta potential, and we'll unpack that as we progress. Now let's just get a bit deeper into the weeds. Mitochondria. Professor Doug Wallace, who is the granddaddy of mitochondrial research, says that, well, he estimates that about every 10 years, unfortunately for most people, their mitochondria go through 10% heteroplasmy. It's because of this superoxide just tearing things apart. So the mitochondria have their own DNA, and it goes through heteroplasmy. So you got mutated, weak mitochondria. So when you breathe, you produce superoxide. Superoxide goes down here and turns into harmless old H2O. Now this one here, SOD2, you need manganese to bind to it so it actually works. Now the dude that I'm helping, he's got low manganese. So this one doesn't work efficiently at all. So he's got a lot of, I guess, poor energy, testosterone, ability to build muscle and proteins. And then also in the mitochondria, we also need SOD2, and that's copper and zinc. So copper and zinc bind to SOD1 and make it work. So in a nutshell, what's actually going on is what you see here. Mitochondrial DNA, that's the mutated mitochondria. That's cancer right there. Deleterious heteroplasmic mitochondrial mutations are associated with an increased incidence of overall cancer-specific mortality. And beyond that, brain. Ataxia, and that's ataxia. That's typical now in a PET scan. Sawdust, your brain's turning sawdust. Migraines and headaches, depression and psychosis, dementia. Of course you got dementia. your moneymaker. Everything that makes you human is turning to sawdust. Stroke, it's not a pretty picture. Heart disease, cardiomyopathy, and you've also got atherosclerosis, plaque. Endocrine disorders, so we're talking adiponectin, growth hormone, insulin, cortisol, sex hormones, thyroid. Kidneys, that further exacerbates heart disease because of high blood pressure, and myopathy. So you could have weak, aching, tired muscles, and you think you need a massage or a jacuzzi, or you might need to stretch it all out. Well, it could be what's going on here. Then neuropathy, numbness in your extremities or pins and needles, liver issues, you can't even detox, and that is huge. The liver is so important. The mitochondria in there are working hard for you, and also the endoplasmic reticulum. You'll have gut issues, hearing, and eyesight. So, pretty important we get this right. Now, as I mentioned earlier there, these ATP pumps, 50% of ATP production, scientists now estimate, that's what's used to create these ATP pumps, like sodium, potassium, calcium. So when you eat food, what we want to make sure is that you've got manganese, zinc, and copper to take care of that superoxide, so it turns into harmless water, and you actually make your ATP. So what is reactive oxygen species? Quite simply, it's a loss of electrons. So I'm going to show you how to gain free electrons, and we'll talk about that as we progress. And just to tie this all in together, the mitochondria, endoplasmic reticulum, both smooth and rough, they talk to each other. So if it's tapping, this is tapping, you can't make proteins. Protein synthesis, as I mentioned earlier there, it's required for collagen, transporter proteins, also in anti-inflammatory proteins, detox proteins, but also testosterone synthesis proteins, and also glycosaminoglycans. So let's bring this all together. We know how important zinc is for protein synthesis. Well, as you can see now, it's not just muscle, it's all protein synthesis in the endoplasmic reticulum, the rough. And when you are trying to make your man juice testosterone, every 2 hours in a healthy system, you make the gonadotropins, FSH, fertility, and LH, testosterone. So there's a protein there, a transporter protein. Endoplasmic reticulum, zinc, magnesium, all of it is needed. So LH binds and it comes down this energy pathway. So you need your ATP there to bind to that protein that's created in the endoplasmic reticulum, and magnesium binds to it so that pathway fires up. Then you need the nitric oxide, blood flow, glycocalyx pathway. They converge onto these other two protein kinases, right? Proteins. They converge on this star protein, the rate limiting step, cholesterol into the mitochondria, and paradoxically, it's making your ATP. So you've got to have zinc and magnesium in there, along with a whole bunch of other micro minerals, enzymatically converted into free T every 2 hours. So that's why the endoplasmic reticulum is important, and I'm going to show you how to lower stress in it today. So in a nutshell, endoplasmic reticulum, transmembrane receptors kind of tap, but all proteins as well. So this is normal, like your receptors are on fire, you're kicking ass, you got energy, you're detoxing, neurotransmission, all of it. But over here, it's just like, far out, dude, I just got no energy, you know. And you feel like a frumpy old dude because your collagen is crap. So your heart, your eyes, you can't see very well, your muscles don't fire. You're getting wrinkles and sagging skin. You got aching ligaments and tendons, your bones, your blood vessels, knee and joints and, everything in your skeletal system. So let's just focus in on blood vessels and collagen synthesis via, you guessed it, the mitochondria, endoplasmic reticulum, but also the Golgi apparatus. So this is a very healthy glycocalyx, and they're glycosaminoglycans made in the rough ER. So you can see how this all ties in together. So when the minerals are in the cells, beautiful. But if the minerals aren't in the cells, and you got a pretty poor net negative charge around the cells, and I'll talk more about that as we progress. Cracks open up, you can see it becomes damaged. The body makes plaque, foam cells. It's a mess. So we don't want that to happen. So just to really zoom into it right now, the mitochondria here, if they're making superoxide and hydrogen peroxide, it's going to destroy the glycocalyx. Then it's going to cause leakage, foam to build up, and you can see there, huge. Zinc and copper need to be ideal inside the cell, endothelial cell, and also manganese, magnesium. It all needs to be in there so you can live a very long, healthy life. And here's more mitochondrial associated endoplasmic reticulum and myocardial ischemia. ER stress. So, number one, you're not even really making on proteins efficiently, but they're misfolded proteins in your heart, your endothelial cells, your muscle cells, your glycosaminoglycans in the glycocalyx. End result for your heart here, DNA injury. I don't think that sounds wonderful. Lipid industry. Injury. So that's the plasma membrane. Lipid peroxidization, apoptosis, cellular senescence, telomere attrition, and protein injury. And your heart and vascular system are proteins. The heart, cardiac muscle, protein, endothelial, smooth muscle, protein. Glycocalyx, same deal. So in a nutshell, your DNA says, okay, let's fix this damaged glycocalyx. So the mRNA comes out into the ribosome of the rough ER, starts to work, and this is where you need ATP, right there. And then the next part is it starts to put everything together and starts to fold it all up, sends it to the Golgi apparatus, and then you need to sulfate it as well. And if you've got low molybdenum, you can't sulfate the glycocalyx, so it's still underpowered. And you're thinking, Mark, what have I got to do? Well, I'm going to show you what you got to do very shortly. And these are all the micro minerals you need inside your cells to facilitate that. This is the endoplasmic reticulum right there. All of those micro minerals need to be in there. And guess what else? As we've talked about, endoplasmic reticulum rough, they make this protein here. It acts like a shock absorber in your knee, and it also lubricates it. Glycosaminoglycans. Now, what is going to protect your endoplasmic reticulum? Well, there's a few things, and let's just talk about one. So here's the lab we got back from somebody, and they've got low alpha-lipoic acid. That's not good. So you need healthy mitochondria to make ALA. As you can see here, alpha-lipoic acid inhibits endoplasmic reticulum. Stress, again, homocysteine induced endoplasmic reticulum. That's why we say get your homocysteine checked. And just so you know, it should be between 5 and at a max 8. North of 10, you got a bit of stress. The endoplasmic reticulum is not working. And when everything is working, your homocysteine will come down in that healthy range. So the body self-optimizes. Right input gives you the right output, which gives you the right outcome for life. So in a nutshell, the endoplasmic reticulum there, beyond that, alpha-lipoic acid, it's going to trigger the longevity pathway. It's like nerve 2 here. Boom. Alpha-lipoic acid, nerve 2. And look at what this thing does. ER stress. Yeah. So not only alpha-lipoic acid's lowering it, but also through this nerve 2 pathway that it's activating. So if you're low in alpha-lipoic acid, that slows down healthy mitochondria. And I'm going to show you solutions to get your mitochondria healthy. Autophagy, so those misfolded proteins in the rough ER, gets rid of them. And also the damaged mitochondria, gets rid of them and replaces them with brand new V8 powered mitochondria. Anti-inflammatory gene expression up, and this TXN antioxidant system is protecting your proteins. Endoplasmic reticulum, all the proteins in your plasma membrane, protecting you. And also the DNA. Heme and iron metabolism, glutathione, the master antioxidant in the up position. You need that in the up position, and the NADPH system. Let me ask you a question. Do you want to repair tissues and organs and build muscle and make proteins? That has to be in the up position. Then all these detoxification enzymes, superoxide dismutase 1, 2, and 3, catalase, glutathione up, all of these important antioxidants are up, and it also sequesters reactive oxygen species. And beyond that, alpha-lipoic acid right here. So all this crap that's coming into our body, we're breathing it in. It's just everywhere now. What it's going to do there is it's going to these precancerous cells, inhibition, proliferation, metastases, diabetes, protecting your DNA. I mean, wow, it's multifaceted again. So just to touch on this here, the multifaceted role of alpha-lipoic acid in cancer prevention, occurrence, and treatment. Alpha-lipoic acid attenuates ER stress, improves glucose uptake. So you need healthy mitochondria for that. Now let's segue into the solution. Solution number one is non-native EMF, and this is well elucidated in the scientific literature. It doesn't take much of a dig to find this out. So phone, Wi-Fi, all of that crap, guess what it does? It opens up calcium channels, and it also causes lipid peroxidization. Enough said? And if you've ever had a heart attack or someone's had a heart attack, they'll put them on calcium blockers. If you've got high blood pressure, calcium blockers. Angina, calcium blockers. Arrhythmias, calcium blockers. Now, beyond that, as I'm always talking about here, circadian rhythm, calcium homeostatic balance at nighttime, cellular senescence down, mitochondrial biogenesis up, neurogenesis up, healthy brain, cholinergic system, rest and digest, anti-anxiety, healthy lipids, neuroinflammation down, healthy insulin and leptin, and these misfolded proteins and tau plaques taken out, and endoplasmic reticulum, misfolded proteins, and beta amyloids. So you got to make sure your circadian rhythm is on point. Now, we also have to make sure, see, this alpha-lipoic acid is the master recycler. It is recycling CoQ10, and that's important for the electron transport chain. If you don't have enough CoQ10, what you'll have is reverse electron transfer through the electron transport chain. Your mitochondria are going to uncouple, reactive oxygen species, lipid peroxidization, heteroplasmy. It's also recycling vitamin C and glutathione, and it becomes oxidized and it recycles itself. So as you can see there, you've got to make sure that you've got alpha-lipoic acid in the up position. Now, you can supplement alpha-lipoic acid, but the caveat, don't supplement too much. All right. It's not going to be the solution. This is not the magic pill. All right. And you only want to supplement a maximum of 100 milligrams. Now, that's what I'd do if I was just starting out. So I'm not giving medical advice out there. If I was starting out and I was a bit sick, I'd probably start with that and see how I feel, because you could get worse by supplementing that, because it chelates heavy metals, and it can also take your glucose into the cell and you can get hypoglycemia. The shakes, you won't feel very good at all. So be very careful with the supplementation of that. But the main way to get your alpha-lipoic back is healthy mitochondria, and we're going to talk about that as we progress. Now, again, with the non-native EMF and artificial blue light, inside your mitochondria, high viscosity. It's sludgy in there. Lots of reactive oxygen species. No good. But when you're outside in natural light there, low viscosity. So there's our first clue. Now, as I mentioned earlier there, in your brain, you got these ATP pumps, and they need magnesium to bind for it to work. So you got to make sure you got optimal intracellular magnesium. And the way to do that is to get a net negative charge. You see, these are the pumps here. What happens is your ATP binds to this protein, the shape changes, but for that to happen, magnesium binds to it, and that's what causes phosphorylation. So if you don't have good intracellular, you can't get sodium and potassium, zinc, you can't get all these micro minerals into the cell. And then if your calcium channels are all over the place because you've got too much non-native EMF or a whole bunch of other things, like you don't have enough manganese, calcium could ebb and flow, and I'm going to give you some solutions for that here today. So we've also got to make sure that you've got plenty of choline. So choline is really important for liver function. So your hepatic production of ATP will decline. You're going to have inflammation. You're going to have your liver enzymes up. And just incidentally, GGT, on a standard lab, they'll say 50 and below is okay. As a maximum, functional optimal is 30 and below. So if it's north of 30, well, you got some liver issues. But you've got to make sure you got to get plenty of choline. 2 to 3 egg yolks per day and a bit of red meat and shit like that is going to give you enough choline. And your plasma membrane. So this is how you're going to understand if your plasma membrane is weak like this. So if you get this test here, there should be more information below. Do you see this? This is no good. This is a weak plasma membrane. Transporter issues. It's no good. You've got to get it in the green. It's very easy to do, and it happens about 12 weeks with the right food coming into your body. Now, as I mentioned earlier there, we've got to protect the cell membrane. Here it is. EPA, eicosapentaenoic acid, the omega-3. So it's incorporated into the plasma membrane, and it blocks lipid peroxidization and cholesterol domain formation. So a simple test you can get is what's called the omega test. And you want your omega index, the percentage of EPA and DHA, the omega-3s, between 10 and 12%. So when you've got between 10 and 12%, you've got superior cellular protection from lipid peroxidization. And the next tool that you can use is, I should have had this right here, astaxanthin. So astaxanthin, you get it from cold water fish, and they've shown in clinical trials now. Now, this is what I do. I'm not telling you to do it. I get about 10 milligrams per day with a fatty meal because it's absorbed with fatty meals. If you have a low-fat meal, it's not really going to be really absorbed there. So it's triggering all these longevity pathways. Now, the really cool thing about astaxanthin spans the entire plasma membrane, and it protects the entire plasma membrane. Now, EPA spans just here. No, sorry, just there. So it's not spanning the entire plasma membrane. And it also sequesters reactive oxygen species. So it's protecting the plasma membrane from reactive oxygen species. Now, the only thing about astaxanthin, it can take on different cells, like your skin cells, regenerate in about, I think, 15 or 28 days. So in about 1 month, your skin cells are protected, but other cells can take 12 months. So it's a long-term solution. And I guess you don't want to go off it, because if you want to get to 100, it's, you can see what's going on there. Now, this is the next solution, and one of the most important steps you can do. You've probably never heard of it before. So you remember the glycocalyx? Well, it's got a gelled water around it. Crystalline water, exclusion zone water. It's called a multitude of different things. And you need 2 things. Well, of course, glycosaminoglycans, healthy mitochondria, endoplasmic reticulum, protein synthesis, minerals in the cells. But the next thing we need to do is we need to get that gelled water around the glycocalyx. But it's not just the glycocalyx. This gelled water is around proteins. Now, I'm going to walk you through what you need to do. Before we get to that place, Professor Gerald Pollack discovered it a long time ago. And he's just going to explain how, basically what you need to do. And I'm going to give you steps after this, but how important it is for proteins. And this is the main focus of what I've been talking about, proteins in your body. The 6,000 to 8,000 proteins that your endoplasmic reticulum is making. So pay careful attention.
Like this on the left side, here is a typical protein in its extended form, and it's got easy water around it. And what happens is the easy water melts into ordinary water, and the protein is able to fold. But of course, it's got to go back to the original position. And what happens is it does as easy water builds around it. So this is the normal function of a typical protein. And on the right side, imagine what happens with no EZ. You see, with no EZ, it doesn't have the potential to get back to its original configuration. And so it's not working. So your muscle or whatever cell is not working properly if it doesn't have EZ water. Of course, if you have some EZ water, then It functions, but not quite as well as if you have a full complement of EZ water. You have potential energy from the EZ, which drives the work of the cell. Light, as I said, is responsible for building the EZ and building negative charge, and that's what gives the cell its energy. And then the energy is consumed as these proteins do the work of the cell, your work, and fold. And if you just connect the dots between the two, so light is actually driving work of your cells, or light is actually driving your function. Well, also inside the cell are structures called mitochondria.
And they need that gel water too, but what kind of light? Well, it's the long wavelengths of light, the far infrared, and I think it's from 2000 nanometers and out. So it's not indoors. It's not going to happen indoors. You got to get outside. Do you have to get out in direct sunlight? No. You could be sitting under a tree, and these long wavelengths of light penetrate through your clothes into your body. You could be sitting on a patio. It could be sunset, or it could be sunrise. You just need to be outdoors. And according to these experts, we need a minimum of 90 minutes to start building up this exclusion zone water. So the more time you spend outdoors in the shade, it's going to be gelling this, giving your proteins extra money to do work for you. Now, another thing that you can do, as I mentioned at the beginning of this, we need a net negative charge. And what does that mean? We need electrons. Electrons give the cell a net negative charge. For example, the red blood cells, I think they're about 10 or 20 negative millivolts. So you can see here, this is grounding, 45 minutes, and the red blood cells. They're all clumped together, so they've got a low negative charge, so they kind of spring together. Now, when you got a negative charge, they spring apart, and that's what grounding does. Electrons go into your body, they give the red blood cells a negative charge, and they spring apart. So your negative charge goes up. And this is Dr. Sarah Pugh, who is a biophysicist, speaking about how important it is to have lots of electrons. So you can get it from food. You can also get it from being outdoors with your bare feet on the earth. Check it out.
Of these happen per second. So that would come back down to why having not enough electrons is bad, because it just means we can't run our chemical reactions in our bodies as well as we could. So that would be another way to describe low redox. So if we can't run our chemical reactions as quickly as normal, then we can't make as much enzymes as hormones, defending molecules and so on, metabolize food.
So you need to gain electrons. You can gain electrons from eating food. You can get it from being outdoors. You can get it from grounding your feet. I guess the medical system don't make any money from that. Dr. Alexis Cohen, 2 videos. So she got her PhD from one of the top metabolic labs on the planet, Princeton.
When I think about bioenergetics, most people think about food. Food is only 1/3 of the story. We also have direct exposure and stimulation of melanin in the skin by the sun. Like I said earlier, that makes free electrons and free energy. And we also have the third pillar being grounding and direct electron exchange from the earth. We're really only getting one of the 3 pillars in the modern day from the food, and most of the food is BS anyways. So our bodies are starving to death. And that's actually how I see diabetes. I'm going to go back to your leukemia story in a second, but diabetes I really see as like the body is starving, because the tissues, the muscle in general, the tissues can't take up glucose very well because insulin resistant. They also can't burn fat or ketones really well either, because the mitochondria are dysfunctional. That's like the root of the issue in insulin resistance and in diabetes. And so if your tissues can't burn anything, they're literally just shrinking away. And that's why we see sarcopenia and like muscle loss and frailty being associated with metabolic dysfunction and insulin resistance. And the tissues just need food. They need support. But food doesn't have to be food that you eat. Food can also be sun on your skin and your bare feet on the earth. People don't realize that. Right. And that's also something I want to study in my light lab, is that like nobody's looking at these kind of interventions, like just putting people outside in nature under natural light, because it's not lucrative, I guess. It's literally free 99. You don't have to have anybody else's prescription to go do it either.
Yeah, that's interesting, that connection with the electrons and like the grounding and the food. Like his food is just electrons essentially at the end of the day, right?
Yeah, when you're eating food, you're eating for protons and electrons.
Right.
Of course, you're also eating for
micronutrients, cofactors, vitamins and minerals, all of those things. Now you see this here. This is what's called a thermograph. And this is getting back to the non-native EMF, Wi-Fi, cellular towers, your phone, all of those things. And guess what grounding does? Let's listen to Dr. Alexis.
Playing barefoot anyways. We didn't talk about grounding, but when your bare feet are in contact with the earth and your palms, you get free electrons from the earth. Negative charge. Negative charge is what powers your mitochondria to make energy. So
when your body is touching the earth,
specifically your hands and your feet.
When your hands and your feet are touching the earth, it's going to give your mitochondria more energy.
Literally, it's free electrons from the earth. And
Electrons.
And you can look at the studies, and we talked about electrons earlier. That's what powers energy production in the mitochondria. But if you look at the studies on grounding, you can see even 20 minutes of grounding, they do thermographs, so they can show basically if there's inflammation in an area, they'll do like full body. So they'll show like there was inflammation in their face. And actually, fun fact, after a cell phone for like a few minutes, you can see the thermograph showing this inflammatory impetus within the face. The tissues of the face are hot. Ground for 20 minutes, everything cools down.
There it is there. Red, inflamed, 20 minutes later, inflammation gone. Now, mitochondria. These are the interventions beyond everything I've just talked about there. So cold exposure, but be careful with that. Sauna can do it. Evolutionary-based foods, and I'll talk about that next week. So stick around for that. So you might want to turn on notifications, fasting, and I'll talk about that. Circadian, I'll touch on that too. And you could be sensitive to fermented foods, so be careful with that. And this is breath holds. So when you hold your breath, it puts a hormetic stress effect on the mitochondria, and you get brand new mitochondria. That said, the most powerful way that you can increase your mitochondria is by HIIT cardio. So if you don't know how to do that, drop a comment below. Now on the call next week, we're going to talk about one of the most important things you need to do to make sure you are hydrated. So this is making sure the transporters can get the stuff into the cells. Magnesium, potassium into the cells so your body can do work. And I'm going to give you the recipe for that next week. So as you can see, legends, we've got a lot of power. Mitochondria, we need them healthy. And I just find it remarkable that these ATP ACE pumps in the brain there, just sodium, potassium, 50% of the ATP are for those pumps. Wow, ADHD-like symptoms. And if the endoplasmic reticulum is sick, you're aging faster. You got heart issues, blood vessel issues, ligament issues. Your skin's getting all wrinkled and saggy, and you've got knee and hip replacements to look forward to. And it's not a pretty picture for heart health, is it? Mitochondrial-associated endoplasmic reticulum membranes. So we want to make sure the membranes aren't tapping out. EPA there, get your omega index between 10 and 12. It's going to protect you from lipid peroxidization, and that's huge. Cellular senescence, telomere attrition. So on the call next week, we're going to really talk about how to make sure these transporters are working efficiently. If you got any questions whatsoever, drop a comment below. My whole game in life is to thrive. And I'm just so curious about how the body works. And if we give the body the right inputs, the body gives us the right outputs, motivation, testosterone, protein synthesis, and not just muscle protein. It's collagen. It's heart health. It's everything. Then we have the right outcome for life. And if we trigger these longevity genes, wow, astaxanthin, alpha-lipoic acid, we're really protected. We're going to have superior cellular performance, superior life performance. This brain fog that we've got, it's going to start to vanish. But if you're the kind of dude that's got a lot of symptoms and you know who you are, erectile dysfunction, you've definitely got some issues with the glycocalyx. You might need to work with a functional clinician to figure that problem out. So if you want any help, you can book a call with me. There's information about how to do that below. So again, mitochondria, mighty important. Endoplasmic reticulum, protein synthesis, transporters, making sure the transporters are working. And I mean, holy cow, again, heart health. It's just incredible. The mitochondria tapping, superoxide, lipid peroxidization, telomere attrition, atherosclerosis, really, really important stuff. And there's all the micro minerals we need in the cells just for the endoplasmic reticulum. And don't forget about the glycosaminoglycans for joint health, glycocalyx, sulfation, alpha-lipoic acid, and alpha-lipoic acid legends. Boom, she's taking care of endoplasmic reticulum stress. So there it is.